Solving systems using substitution method. Focus for intervention today. Let's look at the system that we have here. 3x minus y equals 30 and y equals negative x plus 14. A few steps for us to keep track of as we go. Write the equations side by side. As we write them, I'm going to fill in the hidden coefficients. So y equals negative 1x plus 14. To find the solution, we need to find both x and y variables, and we have two equations. Look for one of the equations that has either x equals something or y equals. So here we have 3x minus 1y, so it's not a 3x equal or y equal. Here we have y equals negative 1x plus 14. So that is the equation that we want to use because we have an expression given for the y variable. We will place that expression in parentheses. So y equals negative 1x plus 14 and substitute it instead of the variable y in the other equation. So this expression is going to come instead of y. That means substitute. Substitute means replace instead of. So the given information instead of y in the other equation. We will substitute and then solve the equation for the variable that we'll see here showing. By making that replacement, you can see now that there is only x variable involved in the equation. So we can solve using distributive property. One times 1 positive 1x, negative times positive negative 14. Equals 30. Combine the like terms, we have 4x minus 14 equals 30. Using inverse operation, we add the 14. And for x is multiplication, so inverse operation will be dividing the 4 on both sides. And we have the x value of the expression now found, which is 11. In the solution, 11 is in the first place, in the x place, and then we still need to figure out the y because we found one of the variables, so we can substitute that number, which is x equals 11, in the second equation. So we're going to take that and substitute it to figure out the y. Y equals negative 1x plus 14. Well, that means negative 1 times 11 plus 14, because now we know that x is 11. Multiply using the order of operations, combine all the terms, and solve for y. Once both variables are found, the solution is found. So the solution is 0.113. if that was on the coordinate plane. One more time to reinforce those rules, we're going to look at the second example and go through the steps again. Follow along with the steps as I go over. Step 1. Let's write the equation side by side. X equals negative 4y minus 4. And 3x plus 5y equals 2. Look for one of the equations that has either x equals or y equals. So we have the first equation here where x equals expression. Put the expression in parentheses and then we can substitute if the problem says x equals negative 4y minus 4. We can use that instead of x in the other equation, which is called substitute. you will have now 3, and instead of x, we substitute negative 4y minus 4 plus 5y equals 2. Once the substitution is made, we will have only y in this equation, so we will solve for y using distributive property, negative 12y minus 12 plus 5y equals 2. Keep solving, combining the like terms, negative 12y plus 5y. Using inverse operation, we add the 12 to the constant sign. Combining the like terms, negative 7y will equal 14, using the integer rules. Dividing by 7, using inverse operation, dividing by negative 7. Positive divided by negative will be negative 2. That is the y value of the solution. The solution has x and y, so x still needs to be found. Now that we know that y equals negative 2, we can use it right back in the equation where x equals negative 4 times. Instead of y, we substitute negative 2 because now we know x will be, using the order of operations, 8 minus 4, which is 4. The solution is found when both variables of the systems are identified. So 4, 2. 4, negative 2. X, y, 4, negative 2. Let's see on the other side what we have here. After the substitution, we'll have an equation with variables on both sides. It's a different way of seeing what's going to happen. Same steps are involved, and we are going to go one by one as we go through. Let's write the equation side by side. As we look for one of the equations that has either x equals or y equals, we notice that both equations have x equals. Well, we only need to use one. So we are going to use one of the equations that has the expression for x, let's say. And what we're going to do is place it in parentheses and then substitute instead of that variable in the second equation. Same rules apply. When you substitute, you create an equation with variables on both sides. So the x equals expression negative 4y plus 1 is substituted instead of x, and now we have an equation that we would solve for y using all the rules that we know about solving equations. Using inverse operations, variables on one side, constants on the other. Combining the like terms. Dividing by negative 5 in order to solve for y will give us the y value. Y value being 1, we can use right back in the first equation to solve for x. Now we substitute instead of y 1 because we know. Multiply. Combine, and the value, negative 3, is the x value of the solution, and 1 is the y value. So the solution is the ordered pair, negative 3, 1.